Okay, so this is the next exercise. We have to show the following properties. It says that A and B are a subset of omega, and we have to show the indicator functions. So if you know that indicator functions means if this is true, then it's equal to 1. If it isn't, it's not. So if this holds true, then yeah, that's basically what it means. So let's just go ahead and do A first. A, this is gonna be just A union B. This is gonna be max of this, right? And we have to define what A union B means. A union B refers to the fact that we return 1 if omega is in A union B, which means, right, that omega is in either A, right, or in B. And then in this case, it's going to be 0 otherwise. So we can use a rule of, we can just use, to prove this, we can use just some truth tables. Pretty easy. So what we do is we basically put W is in A, omega is in A, omega is in B, right? We duplicate this, and duplicate it once more, I think. Oops. Once more. Oops. And let's see, the next one is going to be this, B, and then we're going to do, what was it again? I totally forgot how we did this. Let me just check it again, because my brain is not working that well. Okay, yeah. And then we do A union B, and we're going to check the max of this guy. So this one like a bit bigger because it's a bit chunkier. So there we go. So let's start with this one, okay? We just start with the normal cases. So 0, 1, 1, 0, and 1, 1. That's it. That's as much as we want to show. So we don't need more variables, so to speak. Oops. I should have done it the proper size, but it doesn't matter. We get a bunch of time. Okay. So we start with this. And we see omega is an A. If omega is an A, then it means that one of A is gonna be also an A. So remember that 1 omega A is simply put 1 if omega is an A and 0 otherwise. So it's basically the same thing as omega being an A. So we do here in this case, it's going to be 0, 0, 1, 1. Same for indicator function of B. So 0, 1, 0, oops, 0, 1. And then in this case, it says omega is in A or B. So we check A or B. So in this case, we check these two columns and we check for the OR function. This is going to be 1, this is going to be 1, this is going to be 1. And the max of 1A and 1B. So we take the maximum value between these two. So in this case, it's going to be 0. In this case, it's going to be 1, 1, 1. And as you can see, they are equal, so we can show that they're the same. Now let's go for the second guy. Is it B or? Yeah, it's B. The second one is asking us to prove that A intersection of B, yes, is equal to the minimum of the two indicator functions. Again, we take our table, duplicate it, and we give enough space for some more explanations here. This is going to be the same. This changes a bit, so we'll just change these. Change this to min, change this to intersection. Right? So in this case, what does one, well, the indicator function of A intersection B translate to? It's 1 if omega is in A intersection B, which implies that omega is in A and B, and then 0 otherwise. So let's check this out. So in this case, we have this one and this one, so it's gonna be 0. Then we check this one and this one, it's gonna be 0 as well. This is gonna be this one and this one, 0. And there's gonna be 1 and 1, so 1. And the minimum between the indicator function of A and B is gonna be 0 here, 0 here, 0 here, and 1, because we only have 2 1s. So they're the same, as you can see, meaning we're done. That's pretty much what we wanted to prove. Okay, so let's go for the next one. The next one's a bit more tricky. C. Oops. C is asking us to check whether or not the symmetric difference between A and B is equal to what? To 1A plus 1B mod of 2. Okay, so let's take this guy, copy, paste, make more space around here. And we want to declare first what this means, so let's just put it over here. So 1 if, right, the symmetric difference is going to be if omega is in A, B, which means that, well, omega is in, and we're gonna see, and we're gonna actually write this now. It's a bit long, but it's okay. The symmetric difference says that it's not the first set is gonna be A with not B, union, right, and B not A. So if we just divide this in different cases, right, this would mean that omega is in A, B, or omega is in B not A. And as we know, we do another simplification in which we say omega is in A and omega is not on B. Or omega is in B and omega is not on A. That's pretty much what we want to say. So using this law, we're going to write now the things we need to check here. Just erase all this. This is going to be the symmetric difference. And we're going to copy this guy, duplicate him, make him smaller, put him there. Perfect. So let's check this out, shall we? We first check omega is in A, so omega is not on A. Let's just check the first column here. Let me just do this column here. Oops, I have to make it chunkier so we can actually see where I'm writing here. Let's check this column first. All right, let's check this guy first. So let's see. It says here that omega is in A, which in this case it's 0, and omega is not on B, which is the opposite, so 1. That's true. Then we do or omega is in B, which is 0, and this is going to be then omega is not on A, which is 1. This is going to be 0, 0, and 1 is going to be 0, or 0 and 1 is going to be 0. Therefore, this is 0. Therefore, we can write here 0. Now we do the next one, right? I'm going to be speeding this up a bit. Oops. I'll just write it with orange, whatever. So omega is in A. False. Omega is not on B, which is also 0. Or omega is in B, which is true, and omega is not in A, which is also true. Meaning we're going to get 0 or 1, which is going to be 1. So 1. Same scenario over here. Here we go, these. Omega is in A, which is true. Omega is not on B, which is 1. And there's going to be omega is in B, which is true. And omega is not on A, which is false. No, hold on. Omega's... Oh, I did a mistake here. This is supposed to be 1. Omega is not on B, so this is 1. And this is going to be just 0. Again, 1 or 0. It's going to be 1. Now the last one, okay? Is 1 and 1, meaning you have to check this little guy here. Omega is in A, true. Omega is not in B, 0. Or omega is in B, which is true. And omega is not on A, which is 0. So 0 or 0 is going to be 0. And we are done with this little guy with a symmetric difference. Now we want to check if it's the same to the indicator functions summed up and then through modulus 2. In this case, we're going to sum these two up. So these two up are 0 plus 0 is 0. And modulo 2 is going to be just 2. No, 0. Right? 0 modulus, yeah. Then we do 1, right? So there's going to be 1 modulus 2 is going to be 1, simply. Same thing here, 1. And then 2, and the last one is going to be adding to 2. So 1 plus 1 is 2. Modulus 2 is going to be 0. There's no remainder. And that is pretty much it. As you can see, these are the same, meaning we have proven that this is true. This is how you solve this one. That's pretty much it.